So, welcome to this short introduction to the assessment of the ZeroWIN case studies. The goal of the assessment basically was to measure the success of the ZeroWIN pilot case studies concerning the environmental targets, which were the decrease of 30% of greenhouse gas emissions, as well as to reach a 70% of overall reuse and recycling of waste, and another reduction of 75% of freshwater utilization. And we wanted to do this by quantitative assessment, and we compared our ZeroWIN pilot case studies to a baseline, and this baseline was in any case a standard technology without any improvements on waste prevention. The methodology we used was the life cycle assessment approach based on the ISO standards and the ELCD guideline. We used for our assessment an attributional approach, and we were modeling with Gabi 6.0, a software system with databases for life cycle engineering, and we used additional databases from EcoInvent, and our life cycle impact assessment methodology was RECIPE. So, what could we reach with our case studies? Perhaps you already know that we had 9 different case studies, one dealing with D4R laptops, another one with photovoltaic, another one with a reuse network, and we had some case studies dealing with the construction and demolition sector, and one automotive case study. And for all these case studies, it was possible within the ZeroWIN project with our pilot case studies to achieve our targets concerning global warming potential and also global concerning reuse and recycling, but it was very difficult to reach the targets concerning water use. This was mainly because very often the use of water already was optimized at one side, and at the other side it was that there haven't been real possibilities to have changes on this. So it was only possible for 3 construction and demolition case studies to reach the goal of reduction of water utilization. To go a little bit more into detail, I want to show you something about the first case study, the D4R laptop, and which strategies turned out to be the best. For example, one thing that turned out that has a very high impact was the use of highly durable wood sourced from furniture industry for the chassis that you can see here. And if a normal laptop, so our baseline, and we change the chassis from the normal laptop to a wooden chassis reused from furniture industry, we would have a reduction of 11% of greenhouse gas emissions and of 8% of the water utilization, and another 32% on waste. Another example from the photovoltaic case study, and here the best strategies. It turned out, for example, that to reuse the steel structure is a very good possibility for savings in of greenhouse gas emissions. So this would lead to 24% greenhouse gas emission reduction. Also, a lifetime prolongation could help very much. The use of off-spec modules, and another example that I want to show you here is if you try to prevent the concrete. If you don't use concrete for the installation of the photovoltaic module, this leads to another savings of 4% of the greenhouse gas emissions. And what you can see here, we reached about 45% for the global warming potential and 91% for the reuse and recycling target. For the reuse network, I just want to show you a detail from a desktop computer. Here, of course, it very much the savings that you can reach depend on the age of the product. The older the product, the higher the savings. And if you have to exchange parts or if you have to do an upgrade, of course, your results will not be that good than if you can take an older computer and use it instead of a new one. So what you can see here, the savings you can reach for a reused desktop computer concerning global warming potential. And you see here the baseline, the new desktop compared to reuse without any exchange and upgrade, and two scenarios with necessary exchange of CD-ROM and DVD-ROM or upgrade of hard disk drive and so on. As a last example, I want to show you the construction and demolition best strategies. Here you can see we have for the construction, we reached 58% global warming potential savings for the case study in the United Kingdom, and in Portugal it was 35%. And we had very high potential concerning reuse and recycling. And with the case study 6 to 8, it was also possible to reach the water target. For the best strategies in this case, it turned out that reuse is of course the very best option, reuse of bricks, for example. And this reuse, of course, avoids waste as well as the production of the new product. And therefore, this scenario is the best option to significantly reduce the environmental burden of the building. It also turned out that metals have the highest environmental burdens, and that, for example, aluminium recycling can show very high impacts. Also, another very important point was the transport efficiency. Volume reduction on site, for example, has high impacts to reduce the environmental, the global warming potential for the construction case studies. So this was very brief. A picture of our case studies. What you can see here now is just an example from the refurbishment case study from the Schwabinger Tor in Munich, where we compared a baseline to an improved scenario, and there you can see our savings concerning the water depletion potential. I thank you very much for your attention. If there are any questions from your side, don't hesitate to contact me. You can see my details and my contact details on the last slide. Thank you.